Now you may recall that we talked about literal equations earlier on in the course, and a literal equation was really a formula. Now sometimes we might want to solve for a specific variable in a literal equation, and sometimes that variable may be a squared variable, so we may need to apply quadratic techniques to that. And so let's have a look at some examples of doing this. Alright, so let's solve for the specific or specified variable. Alright, part A. Let's suppose I have a b equals 1/3 pi r squared h. And we want to solve this for r. And notice that r is squared here. This is actually the formula for the volume of a cone, a right cone. So we have to isolate r. Okay. Now, to do that, we need to see if we can actually get it into a form where we can apply one of our quadratic techniques. So the first thing I'm going to do is going to multiply both sides by 3. And then these two numbers here are multiplied, so I'm going to get r squared by dividing it by both sides by pi and h. Now notice that this is in the form x squared equals k, and so we know how to deal with this. This is going to imply that r is going to be equal to plus or minus the square root of 3v on pi h. And that, of course, will be our solution, right? But of course the square root here is going underneath all of this, so to get into the proper form we would actually multiply the top and the bottom by the square root of pi h, and so we'll end up with plus or minus the square root of 3v pi h over pi h, and that would be our solution. Now of course if we were dealing with a real formula here where this was a volume and this was the radius, then of course we would have to make sure we'd only have the positive one. But mathematically that's what we'd get for this particular case. So what if we have this type? What if I have a y squared and a y, and this is equal to 3p, and I've got m is not equal to 0. Okay, and we want to solve this for y. Now notice that we have a y squared, we have a y, so if I was to write it like this, I really have this in standard form, which tells me that a would be 2m, b would be negative n, and c would be negative 3p. And so using my quadratic formula, what I'd end up with here is negative b would be negative of negative n plus or minus a square root of negative n squared minus 4 times a, which is 2m, by c, which would be negative 3p, over 2a, which of course will be 2 by 2m. So this would mean that I'd have an n here, because negative by negative, plus or minus, I'd have an n squared, let's have a look here, we've got negative by negative is positive, 4 times 2 is 8, by 3 is 24, mp, all over 4m. Alright, and so this then would be my value for, for y in this case, because we're finding y would have been our x in our standard form. Okay, so this would be y, so our solution then is that y can be found by simply using this formula. Like so. And so that's how we can apply quadratic techniques to solve for a specific variable that may in fact have a an exponent of 2, so it could be in quadratic form.